In this lecture, I will explain the basic concept of discrete time Fourier transform. Actually, the discrete time Fourier transform DTFT is a mathematical transform used in signal processing to analyze the frequency content of discrete time signals. It converts a discrete time signal, which is a sequence of numbers, into a continuous function of frequency. If a discrete time signal xn, then here n is an integer number, the discrete time Fourier transform is defined as x of e to the power j omega equal to summation of n equal to minus infinity to plus infinity x of n into e to the power minus j omega n. Here x of e to the power j omega is the discrete time Fourier transform or DTFT of the signal of xn, and omega is the normalized angular frequency, typically in radians per sample. J is the imaginary unit, and the range of digital frequency is 0 to 2 pi, and the range of angular frequency is minus infinity to plus infinity. We can write x of e to the power j omega equal to x of omega. If we take discrete time Fourier transform of discrete signal x of n, then we will get x of omega, and x of omega is summation of n equal to n equal to 0 to infinity x of n into e to the power minus j omega n. And if we take inverse discrete Fourier transform, if we take inverse discrete time Fourier transform, then we will get xn equal to 1 by twice pi integration of 0 to twice pi x of omega into e to the power j omega n into d omega. Now I will discuss properties of discrete time Fourier transform. Now the periodicity property of discrete time Fourier transform, x of e to the power j omega is periodic with a period of twice pi. This means that x of e to the power j omega plus twice pi is equal to x of e to the power j omega. This is periodicity property. Now in linearity property, the discrete time Fourier transform is a linear transformation if yn equal to ax1n plus vx2n, then y of e to the power j omega equal to ax1 into e to the power j omega plus vx2 of e to the power j omega. And If we consider time shifting property, if the signal of yn equal to x of n minus n naught, the shifting is minus n naught, then y of e to the power j omega equal to x of e to the power j omega into e to the power minus j omega n naught. In frequency shifting, if the signal of yn equal to x of n into e to the power j omega naught n, then y of e to the power j omega equal to x of e to the power j omega minus omega naught. In convolution property, the discrete time Fourier transform of the convolution of two signals is the product of their individual discrete time Fourier transforms. If the signal of Zn equal to x of n convolution hn, then z of e to the power j omega equal to x of e to the power j omega into h of e to the power j omega. Now a property is Parseval's theorem. The total energy of a signal in time domain is equal to the total energy in frequency domain. This is Parseval's theorem. This is the properties of discrete time Fourier transform or DTFT. Now I will discuss about applications of discrete time Fourier transform. In filter design, discrete time Fourier transform is used to analyze the frequency response of digital filters. In signal processing, it helps in understanding the frequency components present in a signal. In modulation, discrete time Fourier transform DTFT is used in the analysis of modulated signals. In spectral analysis, DTFT helps in computing the spectrum of a discrete time signal, which is crucial in various fields such as telecommunication, audio processing. Here's I ending the video. Thank you.